It's been said that the transport layer of the OSI model provides end-to-end communication control. And while that's true, it's only half of the story, because the transport layer of the OSI model actually provides protocols that are connection-oriented as well as protocols that are connectionless. What you should know is the contrast of the differences between these types of protocols. TCP, Transmission Control Protocol, and SPX, Sequence Packet Exchange, are connection-oriented protocols. That means that they are acknowledged. Every packet that is sent has to be acknowledged. Basically, the packet carries with it a little electronic picture, a little polynomial that allows the system to be able to check to see whether the packet was delivered intact. If the packet was delivered intact, then the system basically says that packet was great, send me the next one. But if the packet was not delivered intact, then the system is simply silent, which will cause a replacement packet to be sent. This is connection-oriented communication. It's set up by creating a session. A session is like a phone call. If I call you, and you pick up the phone and you say hello, and I say, hello, this is Bill, then you know that you're talking to Bill, and I know that I'm talking to you. That way, any communication that happens between us, it's already understood that the session is created. So, at the connection-oriented layer, in the connection-oriented protocols in the transport layer, we have protocols that set up these sessions, and as I said, they're sort of like a phone call. They're also dependable and guaranteed because of the fact that once the session is set up, we can transfer the packets, and because of the fact that the packets are acknowledged, then the communication is much more reliable. But this reliability costs us in resources. They're very resource intensive. In other words, when we are sending information and we're requiring acknowledgments for every packet, then it's going to take some resources in order to provide those acknowledgments. Now it gets a little bit more complicated as to exactly how that's done. Actually, several packets can be sent. There's what's called windowing. And you don't need to know all about that for a Cisco test, but different types of applications and different types of operating systems use TCP/IP windowing, for example, in different ways. They may send several packets and then have timers on those packets. But all of this is resource intensive. So what about applications that we just want to send information, but we do not have to have an acknowledgement, because maybe the application itself is the acknowledgement. Maybe the application is sending a video through the network, and if we can watch the video, then we know that the packets are getting through. Then we don't have to have those acknowledgments of every packet, so therefore it would be much less intensive in regards to resources. Protocols like UDP and IPX are also at the transport layer. UDP and IPX provide for connectionless communication. IPX is actually at the transport layer as well as it performs as well at the network layer to provide for addressing. But UDP, User Datagram Protocol, is used primarily with TCP/IP related applications that are not necessarily that don't necessarily need to have acknowledgments. As we said, a video would be one of those types, or perhaps DNS that's constantly communicating with other DNS servers, and if this one doesn't get through, the next one will. So it's connectionless. It's like a broadcast, like a TV broadcast. You turn on the TV and you're watching your favorite show, but your favorite show does not necessarily know that you're watching it, not unless you're a Nielsen family or something. But you turn on the TV, you can receive a broadcast, but that doesn't necessarily mean that you have a two-way communication with that, and there's no guarantee that you are receiving that broadcast. So UDP and IPX are not reliable. The connectionless protocols are not reliable protocols. They are at the transport layer, and they are with the reliable protocols such as TCP and SPX, but they in themselves are not reliable. And so therefore they use less resources, and that's why we would use that type of a protocol. You might think, well, why do we use it if it's not reliable? Well, we use it when the resources are the key. In other words, we'll get the information. It'll happen. We send it so often, it'll happen. We'll get the information, or we'll watch the web video, and that way we'll know that the packets are being transferred. What we want to do is we want to use the available bandwidth that we have in the most efficient way possible. We want to use the least resources as we can. So that's why we would use some of these connectionless protocols. Main thing you should know about the transport layer is that it does provide both connection-oriented as well as connectionless protocols. And what it does is it creates packets, and it sends those packets through the network. But in order for it to send those packets through the network to get to the right location, it has to put a logical address on those packets so that they can get into the right general location so that the physical address can be used. This logical addressing happens at the next layer down in the OSI model, which is referred to as the network layer. We'll talk about the network layer next.